All right, we know how to determine if a function is one-to-one, and we know how to find the inverse when we are giving a list of ordered pairs. We just flip the x and y. So now let's figure out how to find the inverse when I am given a function that I know is one-to-one. We have 4 steps. The first step is that we want to replace f of x with y. Okay, we know that those equal each other. So we're just going to make it into a little bit better notation for us. So replace f of x with y. Step 2, we're going to interchange x and y. Just like we do with ordered pairs, we switch x and y. We're going to do the same thing here. We're going to switch or interchange my x and y. After I do that, I'm going to solve for y. And after I solve for y, I'm going to replace y with my function notation for the inverse. So f of -1 of x. Okay, so let's try example 5, find the inverse. And then I want to graph f and my inverse on the same coordinate axis. So I'm going to rewrite my function down here. Okay, so my first step is to replace f of x with y. So I've got y equals 2x minus 2. Then I want to interchange my x and y. So now I've got x equals 2y minus 2. Step 3, let's solve for y. So how would I get y by itself here? Well, I'm going to add 2 over. So I get x plus 2 equals 2y. Divide by 2. And when I divide by 2, I'm going to divide everything by 2. So I'm going to get y equals 1/2 x plus 1. And then my last step is to replace y with my notation for the inverse. So this is the inverse of x equals 1/2 x plus 1. So now let's graph both of these. So I'll go ahead and graph the inverse first, because why not? This tells me my slope is a positive 1/2 and that my y-intercept is 1. So I'm going to start right here at 1. And my rise over run is 1/2. So up 1 over 2, up 1 over 2. And I'm going to go this whole chart just to make this as beautiful and accurate as possible. And I'm going to go down 1 over 2 in the opposite direction. Oops, not there. Okay, so here is my inverse. And now I'm going to graph my function on the same thing. And luckily, it's already in the right form we need. So my slope is 2, which is the same as 2 over 1. And my y-intercept is -2. So we go down -2, and I'm going to go up 2 over 1. Up 2 over 1, and I'm going to go again along this whole graph. And here is my function. If you want to see how they are reflecting across the y equals x axis, you can draw that in. And you can even see really nicely with that ruler here that it mirrors the top and the bottom of this perfectly. And you can also look at the ordered pairs over here. This ordered pair is 6, 4, and then I have a pair at 4, 6 when I interchange those x and y. Over here, I have the ordered pair -4, -1, and then I have -1, -4. All those points have been interchanged perfectly. Now, one thing we're going to have to do is be able to verify that my inverse is the inverse of x or of f. And the way we do that is by using some composition. Okay. So I'm going to rewrite this down here just so I can see it and that you guys can see it from the video. Sorry, this is driving me nuts. Okay. My f of x equaled 2x minus 2. And my inverse equaled 1/2 x plus 1. So if I start with this one here, we have f of -1 of f of x. Replace our stuff. What does my f of x equal? Equals 2x minus 2. And now take your function and where you see an x, replace it with 2x minus 2. So I'm going to have 1/2 times, in place of this x, I have 2x minus 2. And then plus 1 on the outside. And then simplify. If I distribute this 1/2 in, 1/2 times 2 is x. 1/2 times a -2 is a -1 plus 1. -1 plus 1 cancels, and I'm left with x. Now, notice that this says that these have to work both ways. So if you get just one, if I get this x here, I can't just assume, yes, they're inverses of each other. It also has to work the opposite way. So, and my definition here, f of -1 of x. Okay, well, what is my inverse here? My inverse is 1/2 x plus 1. And so now I'm going to take my function, and where I see this x, I'm going to replace it with 1/2 x plus 1. So we get 2 times 1/2 x plus 1, and then minus 2 at the end. Distribute your 2. 2 times 1/2 is 1 or 1x. 2 times 1 is 2. Then these cancel, and I am left with x. So because these both equal x, not just one or the other, because they both do, I can say that I have verified that these are inverses of each other. Okay, here's our last example of the lesson. We need to find the inverse and we need to verify it. So here are my steps. First, I need to replace this f of x with y. So I get y equals x cubed plus 5. I need to interchange my x and y. So this becomes x equals y cubed plus 5. And I'll solve for y. So I'll subtract my 5 over. X minus 5 equals y cubed. The opposite of cubing something is to take the cubic root. So I get y equals the cubic root of x plus 5 or x minus 5. And then my last step is to replace y with your inverse notation. So my inverse equals the cubic root of x minus 5. Now it tells us to verify, and we're going to verify here in a second, but you can look at this on your graph. If I put in my function, x cubed plus 5, put in your inverse, the cubic root of x minus 5, you can graph that. And there's my inverse. And we can even make this a little bit more visual and put in our y equals x. And you can see there, they are mirror images of each other. But we're going to verify this algebraically. So first we have this one here. So what was my function? Well, my function was x cubed plus 5. So replace an x from this with my inverse, where I see this x, I'm going to replace it with 3x plus 5. So this becomes the cubic root. This x becomes x cubed plus 5, and you still have a minus 5 under here. Those cancel, so I'm left with the cubic root of x cubed. Well, the cubic root and cube cancel, and so I have an x. This does not verify it. You have to do this both ways. So my inverse function is the cubic root of x minus 5. What was my function? My function was y equals x cubed plus 5. So where I see this x here, I'm going to replace it with this. So this becomes the cubic root of x minus 5 cubed. That's this portion here, then plus 5. Again, the cubic root and cubed cancel. I have x plus 5 or x minus 5 and then plus 5 on the outside. Cancel. And we have another x. So those are not only inverses of each other, but they're verified inverses of each other.